Bienvenidos, Ushamdi, and welcome. CTS231, Section 841 students for the second 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 4 or the Connecting Networks V6 course from Cisco Networking Academy. And this morning's video tutorial and solution set is going to be on Packet Tracer Activity 4.2.2.11, where we're going to be configuring ACLs for a second time. So we've got a second activity here. ACLs are going to be very, very important, not just on the CCNA exam, but when you move into a real-world enterprise environment. You're definitely going to have a control and understanding of both standard and extended ACL. So let's go ahead and dive into this activity. As you can see, we've got a little different looking network here, right? We've got PCA and PCB and then this switch C over here. Now, a couple of key points to remember, and I want to continue to drive this home. Remember that these extended and standard ACLs are nothing more than stateless packet filters. And what I'm going to do right now is I'm going to show you what I mean when I say stateless. So this is the firewall that I use that's connected to my Verizon business line. And so the Verizon Fios business line connects directly into this firewall. And this is what state information looks like, or stateful information looks like, right? This is an ASA 5510. And this is what stateful information looks like. So when I say stateless, it means that it doesn't have all this information. And so let's examine some of these lines here. We'll take a look at this line right here. So shows me the protocol, right? So here's the layer 4 protocol, it's UDP. Here's the interface, right? The outside interface on which it's seeing this traffic. And there is an address, and there's my port number, 123. So this is NTP, right? And then you can see the inside interface. So from the outside, excuse me, to the inside, and it's going to 192.168.1.2 on port 123. We've got idle time, right? So it's tracking the state of the idle time, right? How many bytes have come through, and if there were any flags, right? So this is an NTP entry, and again, it's maintaining, the firewall is maintaining this state information. If we were to look up here, let's see, a little HTTPS. So here we go. So TCP from the outside interface, right? And there's our port number after the colon, the 443. Here's the inside interface. And so from looking at this, you can definitely see we're going from the inside because there's a random high port number, and I'm doing something, I'm looking at something on, and I don't know what that is, but it's a website, right? And it's on HTTPS. But again, this is that random high port number. And so that's the source port number. So from the inside interface to the outside interface on port 443, there's the idle time. Here's how many bytes have been exchanged. And then we've got some flag information. So this, right, is state information. And ACLs, right, standard and extended, are not tracking this state information. They are simply packet filters looking at each packet's information, whether it's layer 3 only for your standard ACL, or if it's the layer 3 and layer 4 information for an extended ACL. And that is the difference. And I apologize for not pulling that up sooner to kind of drive this home. But the other correction I wanted to make, and we'll see it in this video, it's a command I don't use a lot. I said I thought it was the show interface, you know, gig 00 or gig 01 to see the ACL there. It's show IP interface, right? Because we're looking at an access, we're looking for layer 3 or layer 3 and layer 4 information. So it's show IP interface, and we'll use that here. All right, so let's dive in. We're going to be doing everything here on router A. So let's get to the CLI, and I'm going to try to avoid grabbing any of those links there. And we'll pull this up here toward the top a little bit, and then we'll stretch it a little bit this way to give us some more room. All right, so what are we working with here? We're on router A. We're going to configure an ACL. Here are the requirements right up in here. Telnet traffic from the devices on the 10.101.117.32, which is our /28 right there, is allowed to go to just that network, right? The 10.101.117.0/27. ICMP traffic is allowed from any source to any destination, and all other traffic is blocked, and that'll be the implicit deny at the end. We don't have to type it in, it's there, it exists. So here we go. Let's get into, before we get into global config, we'll go from user exec to privilege exec into global config, and we're going to be doing an extended ACL, but it's going to be a numbered ACL. So we're going to say access list 199, and what type of ACL is it? Oh, I'm sorry, we're not doing the name, so we're going to be doing permit, and we're going to say TCP, right, because we have our choices here of the protocols, the layer 4 information, and the source network is 10.101.117.32, right? It's this network that's right down here. So they give us that information, 10.101.117.32. Now we need a wildcard mask in here. Now it says that we can do the subtraction, but let's do it the other way we saw, the way that we don't often use, which is, okay, well, I see that we've got this /28 here, and we've looked at that. In that last octet, we would borrow those first 4 host bits, the high order bits, and make them network bits, leaving the remaining 4 bits for host bits. So the wildcard mask would be 8 plus 4 is 12 plus 2 is 14 plus 1 is 15. So that's also another way to get that information. The other way, which is what they're kind of leading to here, is we subtract 255, 255, 255, 240 from the all 255s, and that would also give us, right, it would yield the same result. So we would say 0.0.0.15, and the destination network is going to be the 10.101.117.0. Now, it says the destination network is 10.101.117.0, but don't be fooled thinking that, oh, it's a /24. No, we've subnetted, right? We've done some variable link subnet masking here. So we're going to need another destination wildcard. And it's a /27, right? It's a 224. And so again, subtracting, it's pretty simple there where they've given us the numbers. We know it's 31. Now, the protocol is equal to what? Right? Well, we've got a limited list of things to choose from. Limited list of things to choose from. So we're going to say telnet because that's what they're asking, right? We've got it's FTP, it's maybe a port number, POP3, SMTP, telnet, www. So we go ahead and we say telnet. It says, what was the first ACL statement? Well, that was the first ACL statement. Now, ICMP is allowed. And here they don't give us a lot of the information. But again, we've just kind of done what we needed to do. So in fact, let's go ahead. I'm going to pull this back. And here, this can kind of save us some time. Because remember, the second ACL statement, it's just saying that ICMP traffic is allowed anywhere. So I'm going to pull this back. Whoops, went a little too far. 199, and we're going to say permit. And what are we going to permit? Well, we're permitting ICMP. And here's where they're going to let us use the keyword or encourage us to use that keyword any. Remember, this is the from. If you get confused, if you ever get confused when you're looking at ACLs, right, just remember that after the protocol, the first either host or subnet definition, it's from and then to. Think of it as alphabetical, that F comes before T. So it's from this network or this host to this network or this host. And so we're going to say that ICMP is allowed from any host or network to, and you can see here it even gives you the destination, right? To anywhere, right? So access list 199, permit ICMP any. And let me double check here, and yep, so we get that added in. Okay, all other traffic is denied by default. Now we're going to apply the extended ACL, and where are we going to make that application? Remember, we want it as close to the source, an extended ACL. We want to try to apply it as close to the source as we possibly can. We talked about why we can't put it here, right? This is a layer 2 switch, Okay, that's not going to help us. We talked about why we can't put it here, right? Again, a layer 2 switch. So this is going to be the closest interface and makes the most sense for us to apply this ACL. So we'll pull router A back up. We're going to get into interface gigabit Ethernet 01, and this is where we're going to say IP access group 199, and again, it's going to be in the inbound direction. Okay, and so you'll notice here it says apply the extended ACL. So the general rule is to place it as close to the source. However, since access list 199 affects traffic originating from both networks, and this is important, right? And this is, we talked about this in class on Tuesday, and I did in the last video as well, that it's a general rule. It's a best practice. It's a recommendation to get it as close to the source interface as possible. However, we now run into the scenario that I highlighted on Tuesday evening that, great, that would be the interface to put it on if that's the best interface to put it on, but it's not. And so remember, let me read out what they've got here. It says, since ACL 199 affects traffic originating from both networks, 10.101.117.48, which is this one here, and 10.101.117.32, which is this one here, the best placement for the ACL might be on the interface gig 02 in the outbound direction. Remember, if they're asking us to apply it here, right, that's as close to both of those sources as possible. And it wouldn't be the inbound direction. This traffic would be going out that interface to try to reach that destination. So here is a great use case for when we're going to apply an extended ACL, not as close to the source as possible, but it makes more sense to apply it as close to the destination as possible, right? And if you're thinking, well, maybe I just put it on both of those interfaces. Let me clear this here real quick. If you're thinking, well, why don't I just apply the same ACL here inbound and the same ACL here inbound? Well, remember, we said that that traffic right there was going to be allowed for Telnet. So if I applied it on that interface, I'm literally blocking all traffic other than ICMP, right? And here's what I mean by that. And that's why that's the interface it has to go on. So the best practice recommendation is to get it as close to the source as possible. But what happens when that's not doable, right? When it doesn't make sense to do that, when that is not going to work, it's going to have a negative effect on the flow of traffic. We would put it here, and that's where we're trying to get it. So let's go ahead and do that. Let's jump back onto the router. And remember, if I was to say, do show access list 199, you can see we're only permitting TCP for Telnet from this network and then ICMP. Well, what if this guy, what if this guy's got other connections that are out here that he's trying to get to? If I applied that ACL here and here, right, I could be breaking PCA's access to other things. Okay, and so that's why we're going to put it here on this gig 02 interface outbound instead of on both of those inbound interfaces. So interface gigabit 02, and this is where we say IP access group 199, and it goes in the outbound direction. So now we've got 100%, but let's go ahead and run through the test. So ping PCB, right, or ping from PCB to all other IP addresses that are out there in the network. And so let's do that. And actually, let me get this. And we don't want programming, we want desktop. All right, so can we ping from PCB? Let's ping PCA first. 10.101.117.51. And maybe an ARP goes out and we miss one, we time out, but then this should work. Request timeout, and there we go. So we've got connectivity. and to all the other networks, and then let's try the VLAN address there. So we're going to ping 10.101.117.2. And so we're going to ping switch C. Remember, the ACL is allowing us outbound, so it should time out, and then we should be able to get out, right? Because we're allowing ICMP any. There we go. And again, if I were to kick it off again, it's now working, as you can see. And that is about it. So we've tested there. Let's telnet from B over to switch C. So we're going to telnet to 10.101.117.2, and we should get a login prompt, and we do. And the password is just Cisco. And there we go. We are on switch C, and then we'll exit off. And then ping from PCA, right? Let's make sure that traffic is working in this direction as well. So we'll ping PCB 10.101.117.35, and that works. And then we'll ping the the switch C address 10.101.117.2, and that works. And then finally, we're going to telnet from PCA. Now, this is the one that should not work, right? We should not have this from PCA to, to switch B. Okay, so they want us to do, so let's do the switch C first. So we'll say telnet to 10.101.117.2. Now this should not work. It should time out because the ACL that's applied to that interface, gig02 outbound, is not permitting telnet connections from this subnet. And we're going to fix that. We're going to go a little further in this activity here to show you how to go back now and to make the change. So we're going to say telnet over to switch B. And what is switch B's address? All right, we don't have switch B listed here. Let's see, can we get on to switch B? All right, so we got a little extra work here. We're going to log on to switch B. We're going to go from user exec to privilege exec. We're just going to say show run. Could have done a show IP interface brief, and it's 117.34. So telnet to 10.101.117.34. Excuse me. And this should work. Remote host not responding. Can I ping that address? 10.101.117. Excuse me, .34. Kind of coming down with a sore throat here. Let's see if some of these pings get through. All right, so I actually can't ping switch B. All right, let's do some troubleshooting. So I can't ping switch B. Let's come to router A, and actually, did I get the right IP address? 10.101.117.34. IP default gateway 64.101. So let's see. Do show IP route. I should have an entry in here for that network out gig01, and I do. And let me ping from here, 10.101.117.34. All right, so that works, and it didn't initially. So let me come back to PCA here, and let's see if we can get 10.101.117.34. Huh. So that's interesting. Not working. All right, let me check the default gateway here. All right, so my default gateway is set there. The default gateway on this switch is set to 64 something. So let's do this. I'm going to do this. I'm going to say no IP, default gateway. And this is probably going to break something else, but let's see what happens here. 64.101.117.33. So it says 64, and I'm wondering if that is not a mistake. Because the IP default gateway should be that 10.101.117 10.33. And let's see, can I ping 10.101.117.33? That should be, yeah. So interesting that that doesn't work because the router A interface is do show IP interface brief. That should be 33. Yeah, it's 33. Okay, so now when we come over to PCA, so very interesting there that the IP default gateway statement was wrong. Okay, so now it's correct. So now when I telnet to 10.101.117.34, which is switch B, which does not have, or the ACL should not be affected by that. So connection timed out, but I should be able to reach it. So that's interesting. And it's still timing out even though there's no ACL. We've got the default gateway, maybe changing the default gateway statement did that. Password Cisco, so the VTY lines are just set for login. So we should be good to go here. And we are not. For whatever reason, we can't telnet. And the default gateway statement was wrong. That's been fixed. The IP is definitely 10.101 and it's timing out. Let me take a look here. And so let's do this. Do show IP interface gigabit Ethernet 01. And here's where you would see if an ACL, and interesting, inbound access list is 199 on gig 01. So did I mistakenly type in that command instead of pulling it back? Do show run. Let's see. So fortuitous failure here. The default gateway was wrong anyway, but that is not supposed to be there. So no IP access group 199 in. Now let's swing over and see. But that, yeah, it works now. So that's interesting because I guess earlier I tried to pull that back and I think I hit enter. And it ended up putting it on that interface. So, but that default gateway statement was incorrect because the default gateway, there is no, I don't even think there is a 64 on here. Do show IP interface brief. But whether that would have broken it or not, I don't know. All right, so one last thing that we're going to take a look at here is we've got this ACL now. So if I say do show IP access list, access list 199, there's the ACL, right? So what if I wanted to change one of those entries in this ACL, right? Now remember, when we created it, we said access list 199 permit, and then we did what we were going to do. But now we want to make a modification to it. So if I were to say do show access list, or not do show, yeah, do show access list 199, you can see it shows us our matches and all that stuff. But if I wanted to make a change here, I would say IP access list. And that's why you see, we're doing an extended, you see the number there, right? 199. Now I can make a change. So if I wanted to put something, let's say we don't want to allow ICMP for one specific host, right? And let's make it, well, PCB. We're going to make a change to PCB. So I'm going to say, we'll put in the number, right? The sequence number. So I'm going to put it right away. So we're going to say 1, deny ICMP, and here's where we put in. We don't want to say any, right? I'm going to pick off a specific host. So we're going to say PCB is no longer going to be allowed 117.35. So from that host, ICMP traffic going anywhere is going to be denied. Now, we lost the 60 points over here for the ACL, but that's fine because we've already sorted that out. But now we're going to be working through this. We've added an entry in here. So do show IP access list 199. You can see we've added this entry in as the number 1, right, in sequence 1. So now when I come over to PCB, and let's get back on the mode of the devices is locked, PCB. So now let's try to ping out to switch C. I'm going to say ping 10.101.117.2. And now we get a destination host unreachable apply. It's coming from our default gateway address, right, which is the 10.101.117.33. And so that's just real quickly how you could go in and manipulate things. But again, fantastic activity driving home the point that I was making on Tuesday evening, which is while it is highly recommended and a best practice to get that ACL as close to the source as possible, when that can't be done, you're going to have to place it in the most appropriate location. Because here we see a great example of an extended ACL placed as close to what as possible? Yeah, as close to the destination as possible. Because again, it didn't make sense to put it here because that wouldn't have affected the traffic flow coming from PCA, right? And it wouldn't make sense to put it there because then it wouldn't affect the traffic flow from PCB. And then it didn't make sense to put it on both of these ports, right? That just doesn't make sense. For the same reasons, this is where the optimal placement of that ACL should be. And so these are things you'll have to take into consideration when looking to place your ACLs. All right, well, that is going to wrap up Packet Tracer Activity 4.2.2.11, where we talked about extended ACLs. We saw the difference between stateful and stateless. In fact, about all the information you're going to get from ACLs is right here, right? 58 matches, 46 matches. It's just every packet that matches, it increments that counter, and that's it. It's not tracking all of that additional information, right? Idle time, port numbers, bytes, flags, none of that, right? Interfaces, what interface am I seeing this in? What's the protocol? We're not tracking all of that stateful information. All right, guys, thanks for watching. I will see you on Tuesday night. Have a great weekend.